Good morning, dear students. In previous class, we discussed about the theoretical concept of chapter 8 motion, and in today's class, we will discuss about some questions based on the theoretical concepts. Okay, let's go. Question 1, you can see, is displacement a scalar quantity? Try to remember the definition of displacement and what kind of quantity we studied it in. Okay, no, displacement is a vector quantity because it has both magnitude as well as direction. Question number 2, state whether the distance is a scalar or a vector quantity. Distance is a scalar quantity, it has magnitude but no specific direction. Change the speed of 6 meter into 6 meter per second into kilometer per hour. Do one thing, find the relation in meter and kilometer and then seconds and hour, then put all the values over there, then solve this and you will definitely get the answer, that is 21.6 kilometer per hour. Okay, let's move forward. Question number 4, you can see, read the statement. What name is given to the speed in a specified direction? We all know, we studied in just third topic of this chapter. Speed with direction is called velocity. Okay, the velocity is a vector quantity because we consider both direction and magnitude. Question number 5, give two examples of bodies having non-uniform motion. Two examples are motion of a bus on a curved road, motion of a bee flying randomly in the air. Okay. Question number 6, name the physical quantity obtained by dividing distance traveled by the time taken to travel the distance. This quantity is speed. We all know the formula of speed is equal to distance upon time. Okay, let's move further. Next question, what do the following measure in a car? Speedometer and odometers. What is their task? Speedometer of a car used to measure the instantaneous speed of a car, and odometer of a car is used to record and measure the overall distance traveled by the car. Okay, got it? If we have to measure the total distance covered, then we will observe it from the odometer, and if we have to find out the speed at a particular instant, then it is speedometer. Name the physical quantity which gives us an idea of how slow or fast a body is moving. Obviously it is speed. Speed is the physical quantity. Next is, under what conditions can a body travel a certain distance and yet its resultant displacement is zero? Okay, the answer is, when the body comes back to its starting point, its resultant displacement will be zero. It is because it has covered a certain distance in due course of time. However, there is no difference between initial and final position. If both the positions are same, initial and final, then the displacement covered will be zero. Okay. Next question is, in addition to speed, what else should we know to predict the position of a moving body? Solution is, besides speed, we should know the direction to predict the position of a moving body. So the direction is also necessary to find out this. Next is, when is a body said to have uniform velocity? If it covers equal distances in equal interval of time in a particular direction. Got it? Direction is the important factor. It is said to have uniform velocity. Question number next. Under which condition is the magnitude of average velocity equal to average speed? Okay, the magnitude of average velocity will be equal to average speed when the object covers equal distance in equal interval of time in a particular direction. Okay, got it? If the objects are moving in the same direction, then both will be same, average velocity as well as average speed. Move to next question. Which of the two can be zero under certain conditions? Average speed of a moving body or average velocity of a moving body? Average velocity of a moving body can be zero. This is because the net displacement for the given time interval can be zero. Question number 14 next. Give one example of a situation in which a body has certain average speed but its average velocity is zero. Motion of a body from the home to shop and back to home in an example of a situation in which the body has certain average speed but its average velocity will be zero because the displacement is zero. Okay. Next is, what is the acceleration of a moving body with uniform velocity? The acceleration of a moving body with uniform velocity will be zero. Uniform means, for example, it is going with a velocity or speed of 60 kilometer per hour. Okay, there is no change in its velocity or speed, then it will be zero. Uniform velocity, sorry, acceleration of the body will be zero. Acceleration we all know can be positive, zero, and negative also. Okay, what is the other name of negative acceleration? We all know it is also known as by the name of retardation. Okay, let's move further. Name the physical quantity whose SI unit is this. Meter per second, it is speed or velocity. Meter per second square, it is acceleration. Okay, or retardation we can also call it. Okay. Next question, what type of motion is exhibited by a freely falling body? Freely falling body exhibits uniformly accelerated motion. Okay. Next question, what is the SI unit of retardation? It is acceleration and having units meter per second square. What is the difference between uniform linear motion and uniform circular motion? Explain with examples. In uniform linear motion, the speed and direction of motion is fixed and it is not accelerated. For example, a car running on a straight road. In uniform circular motion, the speed is constant but the direction of motion changes continuously and hence it is accelerated motion of earth around the sun. Okay. Next question. Dear students, don't go by the serial number, just focus on the questions. Numerical ratio of displacement to distance of a moving object is, find out the correct one. It will be distance or displacement, they can be either equal or less than 1. Okay, displacement is always smaller than or equal to distance. Okay, in the last one it is distance, not displacement. Okay. Next question, a boy is sitting on a merry-go-round which is moving with a constant speed of 10 meter per second. This means that boy is it. Options are at rest, moving with no acceleration, in accelerated motion, moving with uniform velocity. Option C will be the right answer. Acceleration is the rate of change of velocity and the velocity of merry-go-round is changing with respect to time. Thus, it will move in a accelerated motion. Accelerated motion. Let's go forward. See this question. Which of the following case of the motion the distance moved and the magnitude of displacement are equal? If a car is moving on a straight road, both will be equal. Option first will be the right answer because in a straight road the distance and the displacement both will be equal. Next question. When a car runs on a circular track with a uniform speed, its velocity is said to be changing. This is because, see all the options and focus on the option D. The car travels equal distances in equal interval of time. Okay, car travels equal distance in equal interval of distance in unequal interval of time. Okay, so if unequal will be the interval, then it is it is a circular track. Okay, the velocity keeps changing continuously as the direction also changing. Next question, which of the following statement is true regarding velocity and speed of a moving body? Velocity of a moving body is always higher than its speed. Wrong. Velocity cannot be more than, it can be equal. Speed of a moving body is always higher than velocity. Speed of a moving body is its velocity in a given direction. Velocity of a moving body is its speed in a given direction. That will be the right answer. Option D. Which of the following could not be a unit of speed? We all know it can be kilometer per hour. Kilometer per hour. S oblique. It is meter per second. It is millimeter per second can also be, but option B, it cannot be distance upon second upon meter. Second meter per meter, never it will be. So option B is wrong answer. Which one of the following is not a vector quantity? This is one. Which one is not a vector quantity? Speed, we all know it's a scalar quantity because it is distance upon time, and distance is a scalar quantity, so the resulting quantity is also a scalar quantity. Others are vector quantities. Next question, which of the following could not be a unit of acceleration? See all that. Meter per second square, it is mandatory, and in option C it is kilometer per second, so it will be a unit of velocity, not for acceleration. Okay, dear students, thank you for listening patiently, and your homework is you need to write all the questions in your notebook for today, and in next class we will discuss some numericals. Till then, goodbye, take care.